Hello everyone, welcome in the third part of my course Microservices with Spring Boot and Spring Cloud. Today we'll discuss communication between microservices. Here is the plan of presentation for the current part of course. We will discuss just the tools used for communication over HTTP protocol. I will show you how to consume REST API exposed by other microservices using REST template classes. REST template is a popular Spring component used for synchronous REST-based communication for many years. Unlike it, Spring Web Client is a relatively new component which has been introduced in version 5 of Spring Framework. It is available within Spring Webflux project. It is a non-blocking client designed for communication between reactive applications. It's based on Reactive project. It can also be used in blocking mode just by calling block method on it. Both these components may be easily included to our microservice architecture by integrating with Discovery using Spring Cloud Commons library. No matter which client you use for communication between microservices, you should always pay attention to focus on handling timeouts and latency properly. Personally, I had a touch with microservices that consumed the whole pool of free threads because they set timeout on communication with other applications on 1 minute, for example. In normal situation, those applications were responding in milliseconds, but in case of any network problems occur, or we just have a problem on the target microservice side, the response time may be dramatically increased. I show you how to handle timeouts on both REST template and web client. We'll also discuss the third popular way of HTTP communication in Spring Cloud with OpenFeign client. Feign is a declarative web service client. It makes writing web service clients easier. To use Feign, we need to create an interface and annotate it. I'll show you what exactly is a declarative client and how to use it in microservices environment. The same as for two previous components, we will configure and test timeouts for it. No matter which client you use for communication between microservices, you will also use a client-side load balancer for providing load balancing algorithm between all available instances of a single microservice. From the beginning of Spring Cloud, it is using a very popular microservices component, Ribbon from Netflix. Although Ribbon has been moved to the maintenance mode and Spring team has announced to start working on a new load balancer in the end of 2018, it's still used as a default load balancer in all Spring Cloud projects. This situation will change starting from the next release of Spring Cloud Train import. However, I'm going to focus just on the new Spring Cloud load balancer. I'll show how to disable Ribbon for your project and how to use and configure Spring Cloud load balancer. The same situation as with load balancer we have with circuit breaker. Since the beginning of Spring Cloud, the most popular component for it was Hystrix from Netflix. It also has been moved to the maintenance mode like almost all Spring Cloud Netflix components. Hystrix was not the only tool that might be used for enable circuit breaking. We could use Spring Retry or Sentinel from Spring Cloud Alibaba, but currently the suggested replacement is Spring Cloud Circuit Breaker based on Resilience for J project. I show you how to use it and configure. For those which haven't attached with Circuit Breaker before, I will explain the basics on simple example. Our sample microservices architecture consists on two microservices, Intercall service and Intercaller service, and also Discovery server Eureka. For the simplification, I removed config server for this part of tutorial. Let's start with REST template. Application Intercaller service access endpoints exposed by Intercall service. We are starting from implementation of the source service. It provides multiple variants of post method, which receives a message, sends response with reversed string message from request, and stores history of conversations inside in memory repository. This conversation includes a pair, a request and a response. Currently, there are two variants of post method, a standard method, which is currently implemented, and also the delayed method, which will be used for testing timeouts on the client side. It is delayed 1 second. Those two methods are almost the same, the only difference is in the sleeping retreat for 1 second. We are also adding two methods that return conversation history. First of them is returning the whole list of conversations, while the second, single conversation object defined by the request ID. Since we use Discovery Server, we may enable a dynamic port feature in the configuration properties. Okay, we have also added required annotations like request body or path variable, and we have dynamic port already set. We are also adding already known properties for Discovery. Because we are using dynamic port, we need to generate instance ID that is unique across all the running instances. Now we are proceeding to the implementation of controller inside Inter-Call-Me service. It injects a REST template bean in the constructor and provides post method for sending text message. The message is taken from path. It is post method. The format of message is converted into the form required by the Inter-Call-Me service. It's being wrapped by call-me request object with auto-incremented ID, and then it is sent to the target service using REST template bean. Okay, now the key fragment of our sample. We need to use service ID of a target application registered in the Discovery Server. Let's use a Discovery Server module from the previous part of the course. And then let's also run an Inter-Call-Me service application. You see, the application Discovery Server has been started. We are starting Inter-Call-Me service. We need to wait a moment. It is listening on the dynamically generated port, and it is registered under expected Inter-Call-Me service name, that can be verified in Eureka Web UI. Now we may move back to the implementation. We are using the registered service ID for constructing target URL. The rest of our implementation is typical. We are also integrating our caller controller with delayed post endpoint and two other get endpoints for searching conversation history. We are using the same service ID to construct the URL of REST template. We are using Kotlin array for returning response from get method provided by intercall service. It's returning the whole list of conversation. And the last method is find by request ID. Okay, so we have everything ready, and now we may start the last application, intercaller service. Before that, we need to register REST template bean. Currently, it's very simple. We are just building it. We're using builder pattern, and we need to annotate it with load balanced annotation. Thanks to that annotation, REST template is integrated with service discovery provided by Spring Cloud. The application is exposed on static port to simplify testing. It is port 8080. Now we can verify it in Eureka, and 2 applications has been started. And let's send some test messages to check out if communication between microservices works fine. We are sending all test requests to the intercaller service. We are using its post endpoint for sending messages. Everything seems to be okay. We can also verify it in the logs. As I have mentioned before, Netflix Ribbon is still the default client-side load balancer. We can verify it here. You see that there are Netflix components visible. To disable Ribbon client, we need to go to application configuration properties and set property Spring Cloud load balancer Ribbon enabled to false. After that change, the application will use Spring Cloud load balancer component. We are also setting timeouts for REST template. We may do it using its builder. It provides 2 methods, set read timeout and set connect timeout. We are setting it to 100 milliseconds. And of course, we are restarting our application to change. And we are sending some test requests once again. Everything works fine. We can verify it in the logs that there is no logs from Ribbon client. And we say that some Spring Cloud load balancer components has been registered on application startup, so the change has been applied to the application. We may also test our slow endpoint with delayed response. As you see, it's returning its read timeout, which is set on 100 milliseconds, while the endpoint is delayed 1 second. So all the requests to this endpoint will be timed out by the REST template. Okay, now we can verify the situation where we are stopping the application. As you see, it has been restarted, but it is still not available for the intercaller service. We can perform some test requests, and you see that it is trying to search the service based on the previous port of the application. The application has been started on a different port, and this information has been registered in Eureka, but we must wait a long time before this information is refreshed on the client side. There are 2 reasons for such situation. First of them is caching on the load balancer side. We may disable it or change time to live to value like 1 second. The second thing is a refresh interval on the Eureka client side. Even if we change TTL to 1 second and we do not change it on the client side, on Eureka client side, the load balancer will access the value which has been taken by Eureka client, but if you leave a default 30 seconds, you'll still wait a long time before it's refreshed. After changing these configuration properties, we may restart the application to check out if it will be refreshed faster. Now you see that it works fine. We only got an error during first call of target service, and the second calls were okay. The next, our topic is usage of Reactive web client. We are starting from defining web client builder bin. At once we are going to configure read timeout and connect timeout the same as for REST template. The configuration with web client builder is a little bit more complicated than for REST template. First, we need to create an instance of TCP client and set both read and connect timeout there. Of course, we need to annotate our bin with load balanced annotation, the same as for REST template. Once the TCP client instance is ready, we need to create a reactor HTTP client connector and set an instance of TCP client there. And finally, we need to inject a connector into the builder object. Now we may proceed to the implementation of Reactive controller. In fact, we are using the same annotations as for a standard synchronous controller with Spring and VC, so there is no difference, but the difference is in returning objects. We are using mono and flags interfaces instead of returning a single object or a list of objects. Our controller will be prefixed with the context path of our controller will be reactive color. And now we are injecting a builder, not a client, a builder into the controller. We are creating a first post method. As you see, it is returning an instance of mono interface with a call me response. It takes message string as an input, and also it's wrapping this message into call me request the same as before. This format is required by the call me service. Now we are creating a client, and we are calling post method using DSL. We are setting the URI using inter call me service ID, and finally we are setting a request body and returning a mono object as a response. The same with post method with delay. This is also returning mono interface. The controller also contains the implementations of two get methods responsible for searching conversations history. The first of them, final conversations, is returning the stream of objects as a flags interface. We are converting a response into the flags using body flags method. In fact, this is all what we had to do. Now we are restart our intercaller service application. It has been restarted, and we may send some test requests. We are using post method for sending messages, and as you see, it is returning a valid response, so everything works fine. We can also test our read timeout. We may perform some request to see it is timed out, and you see that it has been timed out by web client. We can also call a get endpoint responsible for returning a history of conversations. It's returning all currently added requests and responses. I have already shown you how to use low-level clients for synchronous communication and for reactive communication between microservices. In the next step, we will discuss a high-level client, a declarative HTTP client, OpenFane. To enable Spring Cloud OpenFane for our application, we first need to include the right starter into Maven dependencies. It is Spring Cloud Starter OpenFane. The next step is to annotate the main or configuration class with enable Fane clients annotation. This annotation is responsible for enabling all the Fane clients defined in the class method. They proceed to declaring an interface of the client. That exactly shows you what exactly is a declarative HTTP client. We need to define interface and the method. The method, we are using exactly the same annotations for annotating these methods as in controller class. So that's a very comfortable solution for us. And signature of methods don't have to be the same as controller, but it must serialize and deserialize JSON in the same way as in the controller. The last step is to annotate this interface with Fane client. The name of Fane client needs to be the same as service ID. In Discovery Server, we also setting a path, which is a color. The same as before, we are creating a dedicated controller for every single type of tested client. So here is a color controller with Fane, created especially for testing Fane client. It's available under path color with Fane. We are injecting interface callme client into the controller. The methods are the same as in controller for testing REST template. We are just changing the client. We are calling methods defined inside callme client interface. After the changes, we may restart our application, and the same as before, send some test request to the post endpoint and get endpoint to check if it works fine. Our application is ready. We are switching to the terminal and send some test requests using curl. We are calling color with Fane context path and sending a message. You see that the response is returned the same as before, everything works fine. We can test some other endpoints for searching a history of conversations. It's also integrated with callme service, so here it's just a list of currently added objects. The next step is configure read and connect timeout for Fane client. We can do it in two ways. Here is an approach to configuration properties. We are using a Fane client config configuration properties, also to use the name of Fane client, and we are setting a read and connect timeout only for this client. Another approach would be final configuration class that contains beans that overrides some default behavior of Fane client. Now we are testing the timeout by sending some test requests. You'll see that. The last component discussed in this part of tutorial is Spring Cloud Circuit Breaker built on top of Resilience4j project. The same as before, in the first step we are going to add a starter responsible for including the project that implements Circuit Breaker on Resilience4j. It is Spring Cloud Starter Circuit Breaker Resilience4j. We don't have to enable anything in annotations, so we may proceed to defining a bin responsible for configuration of Circuit Breaker. We may configure a single circuit breaker or define a default configuration for all Resilience4j circuit breakers defined in our project. We are creating a default configuration. We are using a customizer which takes us Resilience4j circuit breaker factory as an argument. We are using a configure default method. And now to the most important things. We are setting a mode for calling methods using circuit breaker for 500 milliseconds. So each request which is longer than 500 milliseconds will be timed out by circuit breaker. And in the next step we are setting configuration of circuit breaker. We are going to change the default value of sliding window from 100 to 10. The size of the sliding window is used to record the outcome of calls when the circuit breaker is closed. It configures the minimum number of calls which are required to calculate the error rate. So we need a lower value than 10 to simplify our tests. For starting the test, we need to add a randomly generated delay into a single instance of callme service. We are going to run two instances of callme service. A single one won't be delayed and the second will be delayed. We are generating a number between 0 and 2000 for a single application. We are using a profile for activating this feature for a selected instance of application. As you see, we are injecting the property from application configuration properties with name app delay. If this value is different than 0, we are generating a number using Kotlin random object and then setting the generated value in thread sleep method. We'll also add some logs that help us in analyzing the behavior of circuit breaker for our application. We are displaying the message and the generated delay for the application. Now we may switch to caller controller. We'll add that a method responsible for calling a delayed endpoint. In fact, it's the same as a previous endpoint for sending messages. We are just adding a random delay to it. The REST template responsible for calling this method needs to be wrapped with circuit breaker. So first we need to inject a factory, a Resilience4j circuit breaker factory into the controller, and then we need to use this factory to create a circuit breaker object. Provides a run method that can be used to wrap the request executed by REST template. We also need to disable timeout configuration for REST template because it is lower than timeout set for circuit breaker, so we want just to test the circuit breaker, not a timeout inside REST template. We'll enable parallel run for callme service. We are going to run two instances of callme service, so we need to change some configuration settings in IntelliJ. And now, as you see, we are starting the application. First instance was started with the delay, while the second has delay feature enabled. Okay, so we have two instances of call me service, and we will also restart caller service after changes. Since we start, we verify it in the Eureka web UI. As you see, we've got two instances of application. Now we are sending 100 requests to the delayed endpoint. As you see that about 20 requests has been sent before a circuit breaker has been opened. You can easily detect it here in the logs of serial method. After circuit breaker has been opened, or the request has been timed out. As you see, we've got about 23 requests before opening a circuit breaker. By default, the error rate of circuit breaker is set to 50%. It means that if more than 50% of recorded requests has been failed, the circuit is opened after checking a request and a number of requests defined in sliding window size. So now we may change configuration of circuit breaker factory and change the failure rate threshold a different value than 50. We can set 66 and 6% to check that something is going to change in the behavior of our circuit breaker. We are restarting our application and send the same request as before, once again. You'll see that currently anything is going to change. We'll also send about 20 requests before a circuit breaker has been opened. That's why, because in fact we need to use a different slow call rate threshold instead of failure rate threshold. We'll also set it to 66. And now we may restart the application and perform a test once again, and you'll see that now the behavior of circuit breaker has been changed, and the circuit breaker has not been closed after sending my request. That's because we changed the failure rate, so it's working. That's everything in this part of our tutorial. Thank you.